All right, so in this video, we're going to take a look at how we can use our logarithms to help us solve exponential equations. Right. So the first one here, I've got 10 to a certain power, so makes it an exponential equation. So what we want to do is we want to try to isolate this part right here. Okay, and then we'll eventually deal with that. So first we need to get rid of the times 4. So the opposite of timesing by 4 is dividing by 4, so we'll divide by 4. All right, so I've got 10 to the negative 3x equals 18 over 4, which reduces to 9 over 2. I believe in Khan Academy, they want you to do an exact answer and then a decimal. So we are going to need to leave this as a fraction for right now. All right, so now I've got a certain number to a power. All right, so to get rid of this, I can't divide because I'm not multiplying. All right, I need to use my logarithm, which is the inverse of an exponential equation. So we talked about this before, how you could rewrite this here. This would be log, the base would be 10, and then we'll talk about that in a second. Then these two things are going to switch places. This was the input, this was the output. That's going to switch. So now the 9 over 2 is going to become my input, and then the negative 3x will become the output. Right, now, just so you know, normally the standard logarithm here is already automatically base 10, so this is unnecessary here. So a lot of times you'll see this, log of 9 over 2 equals negative 3x. All right, now this is just a number, okay? It's some sort of decimal most likely. All right, we'll leave that alone. So for the exact answer, we just need to get the x by itself. Well, you're multiplying that by negative 3. So we're going to divide by negative 3. So the exact answer here is the following. Log of 9 over 2 over negative 3. That's equal to x. And then if I want the approximate answer now, I'll have to either use my calculator or Desmos. And most scientific calculators will have just a plain old log button. So you can just type in log, parentheses 9 over 2, and then divide by negative 3. And in Desmos here, I can do basically the same thing. I can type in log, OG, all right, parentheses, parentheses, 9 divided by 2. Okay, and then I want to take this whole thing, divide that by 2, or was it negative 3? All right, so that's what I had there. So it says that's negative 0.217. I forget how many decimal places they wanted, but rule of thumb, 3 is probably good enough. So that means x is approximately negative 0.217 or 218. All right. Okay, so this e, very similar idea. It's actually it's a number similar to pi. Like pi is approximately 3.14. We use it a lot for circles. E is another number that occurs. We use it a lot for continuous growth and whatnot. So we're going to treat it very similar here. Let's see here. So I want to get this by itself so I can do some sort of logarithm with it. So I got to get rid of this 0.5. So I'll divide by 0.5. So I have e to the 4z equals, that makes 26. Okay, and then now again we'll use our logarithm rule here. So I've got log base e of 26 equals 4z. Okay, now this time we normally don't write this. You almost never see this. This we actually use something called the natural log. So anytime you have a log base e, we use this. You'll see it a lot more in pre-calculus next year. It has a lot to do with continuous growth. A lot of things grow continually, things in nature. So we use this a lot, actually. So I've got the natural log of 26 equals 4z. All right, again, I want to do this exactly first. So we're going to leave this alone. This is technically some sort of number or a decimal. We just got to get rid of the 4 in front of the z. So divide by 4. So z is equal to the natural log of 26 all over 4. And again, I can just type that into A lot of calculators will also have an LN button. You've probably seen it before and wondered what that was. that's what it is. In Desmos here, similar idea here. I'm just going to type in ln. It recognizes that and knows what it is. We had 26. And then we were going to divide that whole thing by 4. And there we go. Looks like, if you can see it, again, 3 decimal places, it would be about 0.815 if I round up. So Z is approximately 0.815. Okay. You'll see one other thing in Khan Academy that you might be aware of. What if it's not a base 10 or a base E, where we can just do log or natural log here? What if it's like log base 2 of 30? All right. Well, there's a change of base rule that says you can rewrite this as log of 30 over log of 2. Oops, of the 2 like that. Or if you're using Desmos, you can just type log base 2 of 30 in there. And I think in your calculator, if you triple tap your log button, it will actually allow you to type in whatever base you want. So, whoops, sorry, I think I was. So log base 2 of 30 was log base 30 over log base 2. That's called the change of base. Or again, in something like Desmos or in your calculators that can handle that, I'll do log. And then here, in the bottom right-hand corner, I go to my my keypad. I've got lots of stuff, but I want to do what's called a subscript here. I want a little number down there. So I hit the ABC button, and then I'll try to raise this up so you can see it right here. You can use that to put in a little number there. So I can put a 2, and then just move my cursor back over, and I can put whatever base I want in for the log there. And then I can do, I think I said 30 in my example. So log base 2 of 30, and it will spit out whatever that is. Or again, if you do log of 30, and divide by log of 2, you will get the same result. So there's 2 different ways you can attack that. All right, hope this helps. Hope y'all are doing well. Take care. Good luck.